Good afternoon. This is John Ross, and I'm here with Roland Sutter today, and I want to welcome you to the webinar we're having here at IKD today on bearings, and we're going to be talking about kiln bearings and bearings, pillow block style bearings for dryers and gears and so forth. Okay, sorry about that. We're just getting started here. Just a little bit about myself. I've been in the industry for over 30 years, servicing rotary equipment like kilns, dryers, ball mills, in the mining, cement, lime, chemical, fertilizer, and so forth. Was a OEM certified kiln and dryer and maintenance instructor, and have done alignments of all sorts over the years, which I've written several papers on. And my colleague here today, Roland Sutter, is he's basically he has a degree in mechanical engineering. He has 43 years plus of experience in fabricating, installing, troubleshooting, servicing rotary kilns, rotary dryers, ball mills, lime processing, hydration system. He's basically, his past existence was with Vulcan Iron Works, Kennedy Van Salm, Alice Chalmers, where he worked as a design engineer, chief engineer, and was president of Vulcan Iron Works. He's an expert in knowledge in finite element analysis, expert on kiln alignment theory, and has authored and published and presented several technical articles. Okay, before we get going here on the contents of the bearing discussions today, I want to just talk a little bit about what we're going to do here in the webinar. Again, we're still fairly new at this. We're getting better every time we do it, but bear with us if we have some little glitches. But if you encounter any technical difficulties at all during this session, you can call this number, this 877-316-6140, mention the troubles, and we'll get you to a person that can help you. We encourage your questions. In fact, you guys that sign into this live webinar, one of the benefits of it is that you will be able to ask questions. But just to keep the material flowing, we've got a lot of material to cover today. Your questions will be answered at the end of the presentation. We'll open up so that you can ask those questions. Just to let you know, we do record this webinar, and we'll have it on our YouTube account so that you can access it later on, or if you find it valuable, you can have other personnel at your company access and be able to share in it. Okay, with that, I'm going to turn you over to Roland Sutter, and we're going to talk about bearings today.
Good afternoon. What we want to cover in this session is various types of bearings used on rotary equipment like kilns, dryers, granulators, etc. And their applications, and also the different types of bearings, spherical roller bearings and the bronze bush kiln bearings. So the main types of bearings used on the ARC type of equipment are spherical roller bearings and kiln bearings. The spherical roller bearing is generally used on dryers and in some applications used on rotary kilns, particularly two-tire kilns.
Roland, and one of the things that the spherical roller bearings are always used pretty much on the pinion gears on kilns as well.
Yes, whether it's a kiln or a dryer, generally spherical roller bearings are used on pinions on the gear set. So I'm going to talk about spherical roller bearings first. They're usually used on smaller units with lighter loads, two-pier dryers or kilns. And kiln bearings are used on larger refractory line kilns that are heavier, more than 2 tires. And also kilns have a factor of large heat loads coming from the kiln shell, whereas spherical roller bearings generally used on dryers which are run at lower temperatures. And essentially, if you look in any bearing catalog, you're going to find 2 different types of spherical roller bearing mounts. One is a sleeve, which is a split ring that has a nut on the end of it that you tighten up to grasp the shaft. It's been my experience that these are, unless you have a very good fit, sometimes these bearings will slip on you, and which is not a good thing.
That's an important point to point out, Roland, on dryer and any of these type of units that you use these pillow block bearings, because they're not really designed to take a lot of thrust, but unfortunately part of the inherent nature of rotary equipment is that you have to skew rollers to control thrust of the unit. So just by the act of skewing the roller, you are going to put some thrust on these things. So the straight line shaft here is susceptible to slippage because of the thrust.
Good point, John. The other type of bearing actually has a step in the shaft where you push the bearing up against that step and then you lock it in with a nut. Most kiln manufacturers do not use that nut with threads on the shaft. They just use an end cap that locks the bearing on. You can see on this picture, there's what we call a stabilizer ring, and we'll get into this later, but essentially on a shaft on a support roller, it's been common practice to lock down one bearing called the fixed bearing and let the other bearing float, taking into expansion of the shaft. If you lock both bearings down, you would get a tremendous force on the bearing, which would make it fail. This is the preferred design, at least in my opinion, rather than the shrink fit type bearing. This is a pictorial of 2 bearings, one fixed bearing and one free bearing. So that if the shaft gets hot, it can freely expand. This same arrangement is used on pinions. There's a lot of discussion about whether you should use that stabilizer ring and lock down a bearing. And John, you had brought this point up before, and
yeah, I've seen several manufacturers go to non-fixed bearing on pillow block bearings because of the thrust situation. If you lock or fix one bearing, that is going to be the bearing that takes the load when you skew these rollers. So if it happens to be that the thrust is shifting towards the other bearing, it's not a big deal. But if the thrust actually shifts the load and the loading into that fixed bearing, it can compound that whole load situation and cause that bearing to fail. And what I've seen on some very large pillow block style bearings is that manufacturers have left both ends floating, and then they have a means to track where the shaft is, and they know which way it's thrusting, similar to a kiln style bearing.
Yeah, John, also we'll see that when we get the kiln bearings, that's the way a kiln bearing works. It's free to float. So it's not like it's never been done before. You'll see other arrangements. This is a dead shaft bearing where the bearings are actually mounted in the sport roller with caps. This is an old style you may have. That essentially you put screws up against the shaft and it moves the whole bearing and roller at the same time. This is really not the preferred way to do it. If you're ever going to change out a bearing design, I'd recommend you go with spherical roller bearings for many reasons. One of them, you go down to the local store and buy a bearing and replace it.
The other issue that you ran into with that style is I've seen like on a drum that had 50-inch diameter rollers that were internal bearing style, and they would actually, because of the big loads on the unit, would crush the inner race because of the load bending the inner race, so they'd seize up those bearings and cause failures on them.
One condition which we see on most all rotary kilns and dryers and like equipment is that we have to deal with a radial load and a thrust load. And essentially with the thrust load, that comes about by skewing your rollers or training your unit. So spherical roller bearings are really good at taking radial loads. However, due to their design, with the kiln weight and slope being excessive, you can't really control the thrust load very well. And it's a very time-consuming task to get the thrust load so it's minimized.
This on these style bearings, more so than kiln bearings, it's very critical to maintain alignment so that you're distributing loads and the actual adjustment of the bearings proportionally so that it's distributed loads on all of your bearings rather than letting one roller or two rollers take all the loading, because that's a recipe for early bearing failures.
So with that in mind, this is a graph of the life of a bearing, calculated life of a bearing. It has a fixed radial load on it. And you can see as we increase the thrust load, it rapidly reduces the life of the bearing. So the point we're trying to make is spherical roller bearings, due to their design, can't take much thrust load. So you got to be very, very careful to distribute the load on all the rollers and get it right. Otherwise, you're going to have bearing failures. Usually, when you design a unit, you design for a life of 100,000 hours, but still you can destroy a bearing very rapidly if you put too much thrust load on.
And I don't know about you guys attending today, but most units are not being run to what they were designed for. So it's not uncommon to see feed rates and speeds increase over the years, which means that you're going to be at a very marginal point with the design of that bearing. So everything kind of stacks up on it. Why? And there again, that's why alignment is so important.
Another concern with spherical roller bearings is, we all on occasion have to shim a bearing, and if we adjust the bearings by shimming to get the proper slope, we got to be careful because although the spherical bearing will rotate in its race to adjust for angular misalignment, the seals become the problem, and you really can only move about a half a degree. So in general, it's best if you try to keep the bearing square with the shafts. So you shouldn't go any more than a half a degree. I know that's hard to measure. But if you had a bearing with a center distance of 16 inches, you can only shim about 0.14 inches. So try to keep the, if your bases are out of slope, fix the bases and then try to shim the bearings.
And that's a common mistake by a lot of people in the industry is they'll keep stacking shims in the base and go through many bearing failures, and probably more importantly the lost production time that costs by doing those unplanned shutdowns to replace bearings. And whereas if they just went in and replaced the base, yes, you've got one shutdown and you've got some cost involved into that, but that eliminates not only the bearing problems, but other problems that are going to be caused by the base not being in slope.
And it's just like any machinery. If you don't have a good foundation, you're going to have troubles. So, as we said, try to minimize the thrust loads and keep the bearing properly lubricated. So that gets down to generally on spherical roller bearings, everybody tells you to use the number 2 grease. And they forget to tell you there's all kinds of different number 2 greases. Especially if you have a higher temperature application, it's actually the designation number 2 grease is the consistency of the grease and has nothing to do with lubrication. So you got to basically look at what the oil viscosity in the grease is. So we just wanted to bring this up because generally it's a misconception that all number 2 greases are the same. Generally use the highest viscosity you can, and we generally recommend 1500 centistokes oil in the grease. And the words always come up, well, should I use a synthetic hydrocarbon or should I just use regular grease? And essentially the advantage of a synthetic hydrocarbon is it doesn't break down at higher temperatures. So since you don't have to change the grease very often, you might as well use the best stuff you can get at the highest viscosity. Now we want to talk about kiln bearings.
Hey, Roland, I just want to say something because we were talking about before this whole started, and the whole idea of this presentation today on bearings is that we're giving you a perspective from rotary equipment on kilns, dryers, and so forth. So, and we're moving into kilns now, but on back onto the pillow block bearings and the dryers before we transition from that. We're not bearing experts per se. We're not SKF or Torrington or some of the manufacturers of bearings that have spent years and years on the designs of bearings. What we are is we are people that have worked in this industry for a long time and have seen various situations with bearings, and so we're coming from that perspective, and I just wanted to clarify that before we moved on.
Okay. Remember we talked about thrust load, and essentially what the thrust load is on a kiln is the total weight of the kiln, including the material, multiplied by the slope in inches per inch. That's the unbalanced load you have to deal with. Doesn't matter whether it's a rotary kiln or whether it's a dryer, it's the same application. There's various kinds of kiln bearings, different designs. The particular one you're looking at is the most common. As we said before, this the roller and shaft assembly can float. Usually there's about 3/16 of an inch clearance when it's thrusting down on the uphill end, so that it can actually move back and forth. And on the end of the shaft, there's a thrust pad, which takes that thrust load that we were talking about. And the radial load's taken by the 180-degree bushing in the bearing. In kiln bearings, you usually use water to cool the bearing. And this is the one area that you have to be concerned about, because using water, depending on what the quality of the water is, you can get contamination and lime buildup. And every once in a while, you have to acid treat the cooling system to make sure it's clean.
One thing unique about these bearings too is, like Roland said, it's a 180-degree bearing, so that means that the bearing liner is actually offset to the angle between the rollers and the tire. So if it's very important that that angle, you hold that angle within a couple degrees. If you start getting too far in with your roller or too far out, it can affect how that bearing liner wears.
Which is different than a spherical roller bearing, which the actual angle that the load's applied to it really doesn't make any difference, except if you turn the bearing upside down and have load up the cap.
One more thing on this one, Roland, is on this style of bearing, this is, Roland mentioned that it's pretty common style. The kind of the nice thing about that is, if you look on that left-hand bearing where the shaft is up against that thrust button, if you took a fairly heavy hammer and tapped on the end cap there, you'd hear a solid sound. If you went to the right-hand bearing, you'd hear a hollow sound. And that would tell you right there which way that roller was thrusting. And that's kind of a handy thing to do with this style of bearing.
And another method that we use to see how much thrust is being applied to, say, the downhill bearing or the left bearing for this example, we can actually put a micrometer measurement on that and actually see the bearing rotate slightly under load.
Right.
So, there's different means to determine what the thrust load is before you have a hot bearing. So, but it goes right back to the fact that when you're training a kiln, a dryer, you got to get the distribution on all the rollers so you don't have one bearing doing all the work. You know, due to the design, essentially, if you get a decent balance, you're not going to have a hot bearing. So these are the different components. There's your 180-degree bushing. You have these oil buckets which deliver oil to a tray, which is in the bearing. And actually, it's all a self-contained, self-lubricating type system. And then you have the thrust disc, which is part of this end cap. And you got seals on here. And one mistake a lot of people make is this particular seal is there to keep dirt out, not oil in. And some people have a habit of over-filling their bearings and having oil all over the place, and it gets on the tires and it becomes a mess. So as long as you look inside of this bearing, you can see oil being deposited on the journal, you're good. Don't keep filling it. Don't let your oiler do this every day, because the oil doesn't go away.
A lot of them will have sight glasses on where they show the oil level, and you want the oil level below the seal, the bottom diameter of the seal. Now the problem with that is a lot of those oil glasses will get plugged and they're not getting an accurate reading. But if you're getting oil coming out of a bearing at all on any style of kiln bearing, you're overfilling the oil.
And there's other kinds of bearings. This particular design has a ring that's bolted on to the end of the shaft, and the bushing has a flange on it that takes the thrust load. All the same principle. You got oil cups, picking up oil, putting on this tray, and depositing on the journal. All self-lubricating. You'll find some bearings that have actually a bayonet type cooling system, which is just copper tubing. You see that on the KBS bearings and Vulcan bearings. You see less of these, but it is another style.
On that particular style, you can't really tell which way it's thrusting by tapping the end caps. You have to really look into an inspection for it and actually view where the roller shaft is at.
And same thing applies to this design. This is the KBS design. They shrink a cast iron ring onto the journal, and that thrust load is taking off that flange on the bushing. Same deal. You got to look in there and see whether you got a gap. You know, if it's thrusting downhill, you'll see like 3/16 of an inch gap up here on the uphill bushing face, and it'll be tight down on the bottom. And that tells you which way you're thrusting, but it doesn't really tell you how much you're thrusting. Another style is F.L. Schmidt style, amongst others. They use a spherical seat, which allows the bearing and bushing to rotate with the shaft. They also use the RingType system to take the thrust load, as opposed to the thrust button. Good design. They have some difficulties with shaft failures.
One of the neat things about this is it's similar to a spherical roller bearing, where you can actually shim under these bearings. So if you did have some base slope issues with the base itself, it is possible to do some shimming under them to be able to get the shaft in line with the kiln or on the correct design slope, which is kind of unique to this style of bearing here for a kiln bearing.
Yeah, John, a lot of the other bearings aren't bolted down to the shaft. They just have a lug on the bottom, which it goes up against the base to give you take the thrust load. And it's a little problematic to start shimming them because I've seen cases where they were over shimmed and that lug broke off and caused a problem. So you got to be careful about shimming bearings that are not bolted down.
Yeah, and just one more point on that is that because there's no pivot in that bearing, if you try shimming on, for example, on an Alice Chalmers style of a bearing or a fuller or something like that, you can run into some issues with the bearing liner not contacting correctly. So it's something you got to be very careful what you're doing.
Okay, now we described different kinds of bearings. They all have the same characteristics, and we're dealing with slow speed journal speeds, high temperatures, all the things that you don't want to do to a bearing. But we have to deal with them. So generally you want to use the highest viscosity oil you can get, which I alluded to on the spherical roller bearings. Same deal. We generally like to use 1500 Centistokes oil. And in cases I've used 6,000, so a heavy oil. And then you get into the situation where, well, should I use a synthetic oil? Should I use a mineral oil? Well, the viscosities are the same at room temperature. But what you'll find is a synthetic oil has a higher viscosity at a higher temperature, which is where you're going to be operating at. So on that basis, you'd want to use a synthetic oil. You can see this is 106 at 100 degrees C, and equivalent mineral oil is like 74. So that doesn't seem like much, but that is a big factor in maintaining a film between the bushing and the journal. The other characteristic of synthetic oils, and oh, by the way, I don't use synthetic oils in my car, so I'm not trying to sell them. But another thing is that synthetic oils, you can run up to like 300 degrees and the oil won't break down. Whereas a mineral oil, you get around 200 degrees, 250, the oil will break down. And then it looks like oil, but it really isn't a very good lubricating properties. So once again, use the highest viscosity you can, and that has something to do with your, your operating conditions. You got to watch if you're doing a cold startup with high viscosity oil, the pour point, the point which it turns into taffy. You got to watch that, and if you're starting up cold, sometimes you have to dump a little oil on the journals to get started. But it's well worth, after you're up to temperature, to use the higher viscosity oils. So once again, I'm not trying to sell synthetic hydrocarbons, but I think that they're worth their weight, because you're not going to be changing oil every 5,000 miles. Main thing is that I do recommend is it's just like using synthetic oil. You get longer life. Temperatures can get very hot in a bearing, even though the oil's relatively cool. Between the bushing and the shaft, I've seen 300, 400 degrees. Oil breaks down, and due to hot spots. And one thing I do recommend, though, that when you use an oil that's going to last longer, test it every once in a while, because it doesn't matter what kind of oil you use. If you get dirt in it, it's going to cause you problems.
And just from a practical standpoint, we saw where they started using synthetics 20-something years ago, and there's several plants that I know of that were having, where they had either marginal designs or excessively hot kilns, and were experiencing a lot of high bearing temperatures that could take them out of production from time to time. And when the synthetics were applied, those issues went away. They were able to maintain running kilns for extended periods of time and not have the hot temperatures in the bearings. So they are very effective in this application, this high temperature application.
As long as you keep the oil clean,
right?
Keep water out of it.
And don't put mineral oil with it.
and yeah, some don't mix well. They can actually turn into a real mess. So if you're going to change to synthetic oil, best to clean out all the mineral oil you have in there and start fresh. So I talked about pour points. You got to watch using high viscosity oil that during a cold startup you could have a problem.
This is true of a lot of kilns that I've seen up in Canada. For example, in the middle of winter, some of the synthetics get real sticky under some of those conditions.
I guess we have another bearing area, which is the thrust rollers. Generally speaking, there's two designs. This one shown here has a radial bushing and a thrust washer at the bottom. Generally, you have to set up your kiln so that there's actually an angle machined on the thrust roller that actually, if you set it on the down running side, it'll actually push the thrust roller down rather than lifting it up. And tie rods are on it. Once again, this is use a high viscosity oil in this application. Don't use 30 weight oil.
Here again, on a lot of designs of a rotary equipment, whether they be dryers or kilns, these thrust rollers are not designed to take the full load of the kiln and on thrust, and that's why you have to skew those rollers to kind of keep the full load of the kiln off the thrust roller. If you do have it where it's exceedingly thrusting against that thrust rollers, they don't hold up very well. They'll fail on you.
Another kind of thrust roller using spherical roller bearings. Same application. Use high temperature, high viscosity grease in these because they see the temperature coming off the kiln. And so just another application. I think what you're finding out, we keep telling you the same story over and over again for our type of applications. Heavy grease, minimize thrust load. That's what you're really after.
That particular style bearing is the common style that we have on dryers with the spherical type rollers. Okay, Roland, thanks a lot for joining us today. We're going to open it up to questions. Can you guys give us a recommendation grease type for a spherical roller bearing? Is a heavier weight generally better due to the low speed and high load? Roland, you want to answer that?
Well, spherical roller bearings in our applications, we generally use a number 2 grease with an oil viscosity of 1,500 centistokes. That would be our general recommendation.
If you do have any questions or if there's any concerns, please contact your IKD representative. They'll be able to get to Roland or myself or somebody in our staff to answer any of your technical questions that you may have. And we really appreciate you joining us today. Thanks a lot.